Welcome back, Year 9, to another exciting class on trigonometry, and remember the following. SOHCAHTOA, sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. It's our key to remembering our formulas. So, what we have here is a question that says that to convert from decimal degrees into degrees, minutes and seconds. Now these questions are given in decimal or fraction notation because fractions can be converted to decimals. And we want to convert them into their degrees, minutes, seconds notation. You may remember from a few classes ago I talked about how angles could be used or measured using degrees, minutes and seconds. And I gave examples similar to this. 25.5 degrees is equal to 25 degrees and 30 minutes because 0.5 of a degree equals 30 minutes, or half a degree equals 30 minutes, a little bit like half an hour equals 30 minutes. So let's see how we can do this using our calculator. Now, when you're dealing with a question like this, it's a case of let's get the answer. So the answer is 34 degrees, 13 minutes and 48 seconds. But let's watch the video. You type in 34.23, push equals, and tap the degrees, minutes, seconds button repeatedly, and you get the answer. Well, our second question, 21 1/3, type in 21 1/3 on your calculator. And when you've typed in 21 1/3, let the calculator movie catch up. When you've typed in 21 1/3, push equals, and now your degrees, minutes, seconds button. And if you keep hitting it, it toggles between degrees mode using decimal degrees and degrees mode using degrees, minutes and seconds. So 21 1/3 degrees is 21 degrees, 20 minutes and 0 seconds, which actually makes sense because a third of an hour is 20 minutes, if you actually were aware of that. So let's try our second example. Same deal, except now we're going to be converting from degrees, minutes, seconds into decimal degrees. So the first thing we're going to do is figure out how to enter this into the calculator. So we go 34, push the degrees button, 22, push the degrees button, then equals, and you just toggle using your degrees, minutes, seconds button, and you'll see the answer, and I've written it on the screen there. Let's try that process again for the second question. 50 degrees, 25, push the degrees button again to do minutes, 10 seconds. You'll notice that when you actually input it into the calculator, it comes up with circle, circle, circle at the top there. Whoops, I've gone too far there. It went circle, 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 and you'll notice when I put it into the calculator, 50 degrees, 25 minutes, 10 seconds came up with this degrees, degrees, degrees. But when you push equals, it fixes it and it puts it into degrees, minutes and seconds. And when you toggle the degrees, minutes, seconds button, it just keeps switching between the decimal answer and the degrees, minutes, seconds answer. So that's the process that you're going to make if you need to do a conversion. Typically speaking, I personally prefer to just use decimal mode unless I'm told to use otherwise. Let's have a look at example 3. Now this is an example where we're told the sine of some angle equals 0.5. And we have to find out what the angle is. Now you can't go, I'm about to write something. Let's write this here. Sine theta equals 0.5. What I'm about to do makes no sense at all. If I divide both sides by sine, the sines cancel, and that would leave you with theta equals 0.5 over sine. Now I told you earlier, in a few classes ago, that sine, cos and tan by themselves are meaningless. They must have an angle associated with them. So they can't be just split up. So when you're doing a question like this, it's important that you understand that to get rid of the sine, we actually have to do something which is called take the inverse sine, or the opposite of sine, to both sides. And the opposite of sine and sine cancels sine out, so we get theta equals the opposite of sine, or inverse sine, of 0.5. Now when you look at your calculator, have a look above the sine, the cos and the tan keys for the gold writing. Above the sine key, you'll find a sine with a little -1 above it. Above the cos key, you'll find cos with a little -1 above it. And above the tan key, you'll find tan with a little -1 above it. Those little gold buttons with sine to the power of -1, cos to the power of -1, tan to the power of -1 are the find the angle buttons. So when you're trying to find an angle, and theta is an angle, you've got to use sine to the power of -1, cos to the -1, tan to the -1. They're pronounced inverse sine, inverse cos, inverse tan, or alternatively, they could be pronounced arc sine, arc cos, and arc tan. But your textbook will use inverse sine, inverse cos, and inverse tan. So on your calculator, the first thing you're going to do is type in inverse sine of 0.5. So the inverse sine of 0.5. How does that work? Well, inverse sine of 0.5. I've accidentally put double 0.5, but that doesn't matter. Do the inverse sine of 0.5, push equals, and it tells us the answer's 30 degrees. And there you have it. Let's try the second one. The inverse cos of 0.2525. Put that into the calculator, push equals. It's important you do inverse cos, not cos. So the answer is 75.4 degrees. If I go to decimal places, you could hit the degrees, minutes, seconds button and write it in degrees, minutes, seconds, but I'm telling you to give it to one decimal place in this question. Part C, to get theta, we do the inverse tan of 1.55. When you put that into your calculator, you'll get 57.3 degrees. And let's try our final one. Sine theta equals 2/5, so we're going to do theta equals the inverse sine of 2/5, and that's 23.6 degrees if we take it to one decimal place. Let's have a look at example 4. Find theta to the nearest degree. Well, the first one says tan theta is 2.555. We want theta by itself, so we'll take the inverse tan of 2.555. That's find the angle button. Put that into your calculator, and it says it wants the answer to the nearest degree. 68.6 is closer to 69 degrees than it is to 68 degrees. So there's our answer to the nearest whole degree. For part B, if you're trying to find the angle when the cos of theta is 0.2525, theta is inverse cos of 0.2525. Put that onto the calculator, and is 75.37450124 closer to 75 or 76? It's closer to 75 if I take it to the nearest whole degree. Let's go to example 5. Now we want to find the angle to the nearest minute. But in this case, we've got to figure out what's going on with our labels. So I'm using the angle here. If I label my sides, which side is 12 and which side is 17? Well, I know 17 is the hypotenuse. It's the longest side. 12 is next to my angle, so it's adjacent. So cos theta equals adjacent over hypotenuse, SOHCAHTOA. So cos theta equals 12 over 17, because 12 is the adjacent side, 17 is the hypotenuse. When you're trying to find the angle, you use the inverse cos button on the fraction. So the angle is the inverse cos of 12 on 17, which, when you put into the calculator, doesn't give 45 degrees 6 minutes. It gives a decimal answer. When that decimal answer is on the screen, just push your degrees, minutes, and seconds button, and that will toggle. If you keep hitting that button, that will toggle between decimal mode and degrees, minutes, seconds mode. Let's go to our next example. Here's our angle. For that angle there, what are these two sides? 11 is the opposite and 10 is the adjacent. Opposite and adjacent. TOA, opposite and adjacent. So it's a tan question. Tan theta is opposite over adjacent, which in this case will be 11 over 10. And because I'm trying to find the angle, theta equals inverse tan of 11 over 10. Put that into your calculator and hit the degrees, minutes, seconds button. And to the nearest minute, it will be 47 degrees and 44 minutes. It's important that you understand that if I have something like this, 47 degrees, 28 minutes, and 15 seconds. Let's say I just had that. When you're looking at the minutes, because there are 60 minutes to equal a degree, you're just looking to see if that number is 30 or more. If it's 30 or above, and I'm going to the nearest whole number, it would become 48 degrees if that was above 30. But if it's below 30, it would stay at 47 degrees if I'm going to the nearest whole number. However, with this question, if I'm going to the nearest minute, you'd look at it and you'd go 47 degrees, 28 minutes, 15 seconds. You look at the seconds part and say, if it's more than 30 seconds, that has to bump up to 47.29. If it's less than 30 seconds, that stays at 47.28. Just be aware of that, and if you're not sure, speak to me in class and I'll go over that with you. Let's try part C. Find theta to the nearest minute. Well, we've got our angle down here. What are our sides? Opposite and hypotenuse. O and H, it's a sine question. So sine theta equals 15 over 22. Because I'm finding the angle is the inverse sine of 15 over 22. When you put that into your calculator and hit the degrees, minutes, seconds button, we're going to find to the nearest minute. It is, let me just put that into my calculator, inverse sine of 15 over 22. It gave, this is the answer, I just want to write this down. It gave theta equals 42.98588. 608. That's the answer that it gives on the screen. But when you hit the degrees, minutes, seconds button, it comes up with 42 degrees, 59 minutes, 9.19 seconds. When you focus on the 9.19 seconds, because it's less than 30, that all stays as it is. And that's why the answer is 42 degrees and 59 minutes. Well, time for you to try some questions. Have fun. Bye for now.